This video is going to cover page 3 from the notes on graphing rational expressions, rational functions. And so I'm going to go through a couple more examples in this video and show you, try to go step by step and show you how to graph these. Before you get started on graphing, the first thing you need to do is look at your numerator and look at your denominator. And we need to factor it, which this is already factored out, so we're okay on that. We are going to take each factor and set it equal to 0 and try to decide what is that answer going to be. And so on this one I get x equals 3. Those items, those factors on the numerator, they go into the zeros. Those are going to be our zeros, our x-intercepts. And so one of them is at 3, 0, and I think you can tell where the other one is without doing the work. That's going to be at -4, 0. The other thing is the multiplicity, and we talked about this last semester. Multiplicity comes from the exponents. So if it is an even exponent, it is going to bounce, and if it is an odd exponent, it is going to bend. If it is just an exponent of 1, it goes straight through. But anything greater than 1, if it's an even, it bounces. If it is odd, it bends. So those are going to be our zeros. So in other words, I can go over here to the graph and I can plot that point and plot that point, and I have those now, and I know that later I'm going to use those. Next, I go to my denominator and I do basically the same thing. I set each factor equal to 0 and I solve it. And so in this case, I get x equals -2. And can you see what the next one's going to be? That is x equals 5. Those are our asymptotes. Asymptotes, we discussed this the other day, are lines which the graph gets closer and closer to. It approaches that line, and it never quite gets there. It might cross it, but it never quite gets there. The other thing is we need to look at multiplicity. Just like on the numerator, the multiplicity came from the exponents. Down here, the multiplicity is also going to come from the exponents. And so we look at the exponents. This has an exponent of 2. 2 is an even number. So that is an even exponent, and that means it is going to go to the same side of infinity. And I know that you don't really understand what that means right now, but in just a minute I'm going to explain it to you. X to the 5th, it has a power. The power is 1, but that's a power. 1 is an odd number, so this one has odd multiplicity from the exponent, and odd multiplicity means that you go to opposite sides of infinity. And again, I'll explain that here. Because of that information, I'm going to go ahead and come up here to the top and just write myself a note to remind myself. This is not part of the graph, but it's going to help me remember what I'm supposed to do. The other piece that we can gain from this is we can look at the end behavior. The end behavior, once again, is going to be the same end behavior that we talked about last semester, but this time I've got more going on. And so what I need to do is I need to kind of estimate that if I look at my numerator and if I multiplied all this all the way out, I would get a really long polynomial, but it would start with an x to the 5th. Because once I multiply all that stuff out, it's going to give me x to the 5th. And the denominator, same thing. If I multiply this all the way out, what is it going to give me? X to the 3rd. And so my numerator simplifies to x to the 5th, my denominator x to the 3rd. Now that is a very brief simplification. There's more to it. But all I care about is the leading coefficients, the leading exponents, the degree of the polynomial. And there is a negative, so I want to put my negative there. That can be reduced, right? What does that reduce down to? That's x squared. And you know what a negative x squared graph looks like. This is what a negative x squared graph looks like. All of this information is all the information we need to put onto the graph. But this is basically like little clues, and we have to put all these clues together. And that's what we're going to do next. I'm going to start by looking at my end behavior. The end behavior, when I say end behavior, it only is with the ends. It does not pay attention to the middle. Basically just these arrows. What it's saying is, on the left-hand side, my function needs to point down, and in this case, on the right-hand side, it also needs to point down. So I'm going to start on the left-hand side. We read a graph from left to right. So I'm going to start on the left-hand side. My question is, should I start at the very top or should I start at the very bottom? Well, my end behavior says start at the bottom. So I'm going to start down here. And that's going to be the start of my graph. Now, I have to figure out where am I going to go? Well, if there is an intercept, an x-intercept, we want to head for that x-intercept. And we want to look at our notes of when we get there, what are we supposed to do? So we're going to head to that intercept, and then we're going to bend a little bit. So I'm going to have to draw up here. I'm going to come up here, and I'm going to give it a little bit of a bend, and then I'm going to go up like this. Notice I'm going to continue up all the way to positive infinity, which of course we'll never get there, but positive infinity is my goal at this point. I'm never going to cross that axis, that asymptote. The asymptote, in this case, cannot be crossed. So, since I can't cross it, I have to look and see, well, what am I supposed to do? I have to hop over it. And the question is, okay, once you hop over it, then what? Well, the even asymptote tells me down here that I should go to the same side of infinity. In other words, I was up here at positive infinity. I need to stay on the same side of infinity. That's the positive infinity side. So my arrow is going to start at positive infinity now. It's going to start coming down, and I need to head towards the x-intercept again. So I need to head right over here. And this time it's going to bounce. So I'm going to head over there, and I'm going to bounce off of it and bounce back up. And I'm going back now to this asymptote and up to this positive infinity. This time, my note says this is odd. Odd down here, odd means opposite. It means if I'm up here, I need to go the opposite side. That's all the way down here. So I'm going to come down here and I'm going to draw my graph. And now where am I supposed to go? Well, I'm supposed to go to an x-intercept. There is no x-intercept. Since there is no x-intercept, I can't go there. In other words, I need to turn around. So I'm going to come up here, but I'm going to turn around, and I'm going to turn back down, and I'm going to head the other way. Now, one more thing. I am now at the end of my graph. For my graph, I go from left to right. I've gone from the left, I've filled in the middle, I'm over the right, and now I have this downward arrow. That matches the end behavior downward arrow. And so now I know I've gone in the right direction. If you're not sure about that end behavior, once again, the end behavior only tells us the ends, the arrows. And so we have this arrow that matches up with this one, and we have this arrow that matches up with this one. Now, don't draw this because I've got a highlighter here, but my shape of my graph is essentially that parabola, that upside down parabola. It's not. It has a bunch of other stuff going on. That's why it's called end behavior. It's not middle behavior. It is end behavior. Okay, that is all I need on this graph. Let me mention a couple things. In the notes and some of the things that we've done in class, we've talked about horizontal asymptotes. We are not going to talk about horizontal asymptotes today. That will be next week. So for today, we are just needing our vertical asymptotes, our zeros, our multiplicity, and the end behavior. Okay, that is one example. If you have questions that you're not sure about, write them down somewhere. Maybe you've got some free space right here, okay? Write down your question so that you can ask somebody. Ask me, ask a classmate, ask the substitute, ask somebody so you can get help on this. One other thing I do want to point out is you have to have something in each part. And so on the left-hand side, I have this kind of bend line. In the middle, I have this U shape. Some people call it a parabola. It's not a parabola. I understand it's a U shape, but it's not a parabola. And then over on the right-hand side, we have another little floater, but it's a piece. It's something going on down here. Lastly, I have not determined how low this floater needs to go. And so that might be really, really low. It might be down like at -900 something. I don't know where it is. I could figure it out. The way I would figure it out is this is a 6. So I could come over to my equation and I could plug in 6. And 6 minus 3 is 3, so 3 squared is 9. 6 plus 4 is 10. 10 to the third? 10 to the third is 1,000. So far I have 9,000 up here. Negative 9,000. Now I'm going to divide by whatever I come up with down here. But my point is that could be really, really low. That negative number is a really big negative number. So I just draw it here just to represent that it is there, but it might be much, much lower. For our causes in this class, we don't really care how low it goes. Let's go ahead and look at the next example. Zeros and multiplicity. Once again, zeros come from the numerator. Asymptotes come from the denominator. The zeros. In this case, I'm going to set the numerator, each factor equal to 0. This negative 3, the negative is going to affect the end behavior. The 3 is not. The 3 just stretches it. And a stretch with these functions doesn't mean a whole lot. So we don't really need that 3 information. We do need the negative, and we'll get to that. But x minus 2, that 0 is going to be at 2, 0. And x plus 3 is going to be at negative 3, 0. I'm going to plot those points since I've got them. I need to think about multiplicity. At 2, it's a fourth power. We haven't really done very many fourth powers, but it is a bounce. Any even number is a bounce. Negative 3 is also a bounce. Next, I'm going to look at my denominator. I have a negative 5. And I'm writing these as equations because they're going to be equations of lines. And I have a negative 1. So my negative 5 is going to go here. My negative 1, yep, going to go here. I need to consider multiplicity. 5 has a power of 1. 1 is an odd number, so that one has odd multiplicity. I'm going to write myself a note that this one's odd. Negative 1 comes from this one. It has an even. It has a power of 2. So that is an even. And so I'm going to write myself a note, even multiplicity. Okay, do you see that there are 3 sections to this graph? And again, I'm just going to use my highlighter here. One section is over here, one section's in the middle, and the other section is over here. So there are 3 sections. That means that each of those 3 sections needs to be filled in with something. And so when we graph this, we're going to make sure that there's something in each section. Well, what is that something going to be? Let's think about end behavior. I mentioned earlier we need the negative sign. And our exponents on the top, if we multiplied this all the way out, we would get x to the 6th in the numerator. In the denominator, we would get x to the 3rd. That reduces. What does it reduce to? X to the 3rd. So our end behavior is going to look something like this. That tells us where to start the graph. We start according to the end behavior. I want to start on the left. On the left, should it be up or down? Well, look, it should be up. So I'm going to have an arrow pointing up. I'm going to come down. And if there is an intercept, an x-intercept, I'm going to hit it. There's no x-intercept. That means I have a floater. My floater is going to get closer and closer and closer to the asymptote. Once it hits the asymptote, I have to figure out how do I jump over. Well, it's odd. It's an odd asymptote, so I have to go to the opposite side of infinity. So if I'm at the top, I have to go to the bottom. If I was at the bottom, I'd have to go to the top. It's just opposite. Okay, so now I'm down here at the bottom. I am going to go towards my x-intercept. I have one this time, that's good. And it tells me I need to bounce. So I'm going to come up here and I'm going to bounce off and I'm going to head towards the other asymptote. Okay, now I have to figure out how to jump over the asymptote. My note says the asymptote is even. Even means you just stick right next to it. You don't have to go all the way to the other side of infinity. You're just right here with it. So you just jump over. Now, I need to head towards my intercept. And again, I do have one, so that's good. And at that point, I'm supposed to bounce off. So I'm going to come up here, bounce off, and come back down. Okay, a couple things to note. Notice there is something in each of the 3 sections. Notice I have a floater over here, and I don't know how high that is supposed to be. It might be way up there at 3,451. I have no idea. Also, my end behavior. I want to go back and check my end behavior. I started at the top, I ended at the bottom. My end behavior said start at the top, end at the bottom. So my end behavior is the same as the end behavior of what I thought it was supposed to be. So my end behavior is correct. Everything I've done so far on this graph, I've done in the right way, so we're good. Let's come down here to the summary. In the numerator, we factor the numerator to find the zeros and the multiplicity. And with the numerator, the zeros and the multiplicity can be through if it's a first power, it can be a bounce if it's an even power, and it would be a bend if it is an odd power greater than 1. Then we go to the denominator. In the denominator, we factor it to find the vertical asymptotes and the multiplicity. On the vertical asymptote multiplicity, once again, it comes from the exponents, so you have to look at the exponents, and this time it's either odd or even. If it's odd, that means opposite sides of infinity. Even means the same side of infinity. The number of asymptotes will determine the number of sections that your graph has. And the number of that is going to be, you take your vertical asymptotes and you add 1 to that, and that will tell you how many sections you're supposed to have. So I want to take a look at what we've done so far and show you an example of that. The very top graph, we had 2 asymptotes. Do you see the 2 asymptotes? Because we had 2 asymptotes, we had 3 sections. The second example, example B, we had 2 asymptotes. They are listed here and they are shown here. And because we had 2, we add 1 to that and we get 3 sections. Now that doesn't have to be always 2 asymptotes and 3 sections. It could be 3 asymptotes and 4 sections, or 8 asymptotes and 9 sections. We won't ever get any that big, but I'm just saying that you just take 1 and add 1 to the asymptotes, and that tells you how many pieces, like how many U's or bends or whatever, how many random little pieces of graph you're supposed to have. And then finally, the hardest part that most people have is, how do I put it on the graph? They can do all of this little stuff, but they don't know how to put it on the graph. So I'm going to talk about how to do that. When you are graphing, start on the left and pay attention to the end behavior. And the end behavior is going to be just like the end behavior we've talked about all year long. And to find the end behavior, you reduce the function to its lowest terms, and then remember what are the positive infinity, negative infinity rules. That will tell you the end behavior. Okay, this has gone through all of page 3 of the notes. If you have questions, write them down. Ask somebody, ask me. I will be back on Monday. You can ask the substitute. We will do practice with this, but make sure you get your questions answered. The assignment is to do the next page in this packet. All you need to do is turn the page. You're going to do the same thing. Look, zeros and multiplicity, vertical asymptotes and multiplicity, and end behavior. The graphs I have purposely set up without a whole lot of y values, a whole lot of room for your y's, because we never know how high or how low it's going to be. We do know we could plug it in. And remember, you can always make a table of values. If you are lost and you don't know where something goes, make a table of values. But realize some of those values might be huge, and so they might not fit on the graph. And that's why I've purposely made my axes like this. I've got a little tiny y-axis because I just don't know how high it's going to be. Okay, do your best on the worksheet. I will be back on Monday, and we can work on it more together on Monday.